Hi guys, Igor here with the next video. Today we will demystify full text search. So what is that? So it's a set of techniques of searching for arbitrary term, phrase in a large set of documents or texts. So like it's a problem like give me all documents that contain where or certain keyword or certain phrase and so forth. So we have a bunch of documents, hundreds of documents, thousands of documents, and we want to retrieve all documents that contain certain keyword, phrase, expression, part of the word, and so forth. So how we do that? Obviously we can just scan documents, but it will not scale if we have thousands or tens of thousands or more documents. So we need to have some data structure to help us with that. And for that we are using inverted index. And why it is inverted, I have no idea, to be honest, because index that we call an index in the database world, for example, is really similar to that, because there you have keys, and with the keys you have associated rows of data, and here it looks really similar, so I have no idea why inverted. But anyways, the structure of the index is that we have a term and a list of documents that contain this term, and the term we see is usually a word, part of the word, or a phrase. So we have simple multi-value map, term and a list of documents. And let's go through example how it looks. So let's say we have three documents, first, 2 and 3, like here, and we want to create inverted index given that data. So it will look like that. We have let's first term and list of documents that contain this word, so only doc1 contains that word. And then we have next term index, also doc1, this doc1, shorter doc1, and the word doc is in the 3 documents. And it's a map, so obviously it is pretty fast and efficient, because if you want to search, if you want to get all the documents that contain doc keyword, you are just looking, you just do lookup to the map. It is very fast and you get a list of documents. So let's talk about tokenization. What it is? It is basically a process of turning documents into terms, the terms that we have as a keys in the inverted index. So first we take a document and we turn it into tokens, and the tokens are almost terms. Let me explain. So we remove some tokens or not, and some we normalize. So the term is really a normalized token. Tokens are like potential terms. So given tokens from the documents, we often remove things like semicolons, like delimiters, periods, and so forth. And the things that we don't want, we often call them stop words. Also, we can have things like a, d, will, punctuation marks that we don't want to have in our inverted index. We often remove them, and we then frequently normalize them. And in practice, it means that in most cases we are changing them to the terms to lowercase, so we can have case insensitive query. So I know that there are quite a bit of jargon, too much words, but I want to introduce that because it is often used in the tools that we use, like Elasticsearch or Lucene. Okay, and one more concept that we have here is our engrams, and basically we need them to search for part of the word. So if we have word mother in our document, we will have this in our inverted index, but let's say that we want to search for MO, so only prefix or TH, so something in the middle of this word. For that we need to create engrams. Engrams are basically analog variations of the term. So with here we have a 2-gram example of for word mother. Basically we have all of two letter long combinations of the word mother. So MO, OT, TH, HE, and R. And we treat them the same as terms. So it basically, besides mother, we would have all of this parts of the words, so engrams of this word in our inverted index, and so that we can do fast lookups also on the parts of the words, not only single word. The disadvantage of this is that it can take lots of memory, so we need to be careful about that. But if you need to search for the parts of the words, you need to create engrams for that. Okay, and more advanced cases. So when I presented the inverted index, here we had only keywords, terms that maps to the document name or document title. But in more advanced use case, we often have documents that have fields, like in this example, title and body, and we index them separately. So we would have index for every field, so sum and body, title and body, and we will have separate indexes for that. We would probably also store more data in the value field for the inverted index. So we will probably store position of this term in the document, so that we can highlight words in the document. We can show where this particular word is in the document. We also properly store frequency, so how often this word occurs in this document. And thanks to that, we can support more advanced use cases and queries. Okay, and I also skipped a few things to make this presentation and example simpler. So often we also have ranking, so this is the measure of to what extent text is matching what we want. So given a query like give me all documents that contain word mother, we may have documents that are having more occurrences of this word, or the word is making more percentage of this document. So we can have arbitrary rules like that, which will tell us how what is the match in percentage terms of the document to our query. And we also have fuzzy and regex queries, so we can support things like that. Not only we can ask for the documents that contain certain term, but also documents that have terms that start with some sub part of the word, or they start with the part of the word right here. Then they have some arbitrary signs, any two signs, and they end with something, and we can support regexes like that. And we also can support fuzzy queries. So these are queries that include typos. So for example, we would query for text and we would get variations of the text clause, small variations of the text, and there is a technique to define that. But for example, text would be matched with these examples. So you have a slight difference in this word, but it would still match. Okay guys, so that's it for the theory. Let's jump into example. I have prepared a code for our example, starting with the main. What we have? We have 3 documents that we are reading from resources here. They are simple documents that I copy pasted from Wikipedia basically. Here I wrote something random, and let's see that we have content of this document read. Here we have it. So let's see, what do we have? We have inverted index, we have analyzer, and we have 2 implementations of the analyzer. So first, we have analyzer interface, and basically it takes text, which is document, that returns terms as I described, and the terms would be here are keys in our inverted index. Okay, and let's go through first main implementation of this analyzer. We have simple analyzer. And basically what it does is given text, it is splitting this by this regex pattern, and this regex pattern basically splits text by white spaces. So we would have more or less individual words here, and then we call them tokens, and we iterate over these tokens and we normalize them. The normalization here means that we are removing some unwanted characters like these ones, so punctuation marks mostly. We remove them, and then we change every term to lowercase to support case insensitive queries. And if this word after normalization is not word or term after normalization is not empty, we are adding it to our terms list. And that's pretty much it. Actually, let's maybe run separate example for that. So let's create analyzer, simple analyzer, and terms for, let's create some document like we are analyzing text, and we should have, maybe let's add new line also, new line, and we will have a few terms like that. Okay, so we have just individual words, and if I would add some punctuation marks, we would not have them. Oh, actually we have one. So why this is the case? We probably should. Okay, now it works. I needed to escape the regex character. Alright, so we have terms from the simple analyzer. Okay, and we have inverted index. So what it does, it has simple map of documents, key being term and the value being list of documents. Okay, and we have analyze in the instance of analyzer. Basically we have add document method where we give a key to our document, some ID, we give document content, and we are using analyzer as we had here to create terms for us, and we iterate over these terms. We put them into this map, and we are adding doc ID so that we have the structure like that: term, doc1, doc2, and so forth. Okay, and we have documents of terms method, which basically will return us list of documents containing given term, and we can investigate terms here. So let's use that actually. So let's create inverted index like that. Let's give it a simple analyzer, and let's add our documents. So document 1, 2, and 3 like that. And let's see what terms we have actually. Okay, we have a bunch of terms. As you can see, there are individual words, right? And so let's maybe query for some of them. So let's take invert index, document of term, I don't know, employee, and maybe let's take career. And yeah, we get doc1 and doc2. Maybe let's ask for something that should be in more than one document, like her. And yeah, it is in document 2 and document 3. So this is a simple case without engrams. And let's now use engram analyzer actually to support engrams. Because right now, for example, if we have employee and we ask for part of this word, like employee without E, we don't get anything. Same if we were to get only this prefix. But we want to have that. So for that we need to use engram. And here we have engram analyzer. So it also implements analyzer, and to recap, the engrams are all mutations, variations, and long variations of the given word. So 3 grams of science is something like that. So it is simply that, then that, and then that, and that here, and finally that here. Okay, and the engram analyzer is using different analyzer, and we'll cover that in a minute. And it takes minimum length and maximum length, and basically engram analyzer is creating engrams in this range. So if we will give it minimum length of 2 and max length of 5, it will create 2, 3, 4, and 5 grams for given term. So how it works is that it is using analyzer that we are giving it here. We have terms from analyzer, and now for every term we want to create all engrams required by these two params. And the way we do that, we iterate over terms, we call term engrams method, and here we are just we are creating engrams from min length to max length, and for each iteration we are calling term engram method, and basically it is creating n length engram for us. And if term is shorter than required engram, we are only we are returning term, and else we create by calling substring with proper indices, we are creating engrams. So actually, let's maybe visualize that first. So let's comment that out, and let's create our engram analyzer, which will use simple analyzer. Let's create maybe engrams from, I don't know, 3 to 5, something like that. And let's create terms. So given some simple text like mother is here, let's examine our terms. Maybe not like that, but like that. Okay. And what we have, it's not sorted, so let's sort it, guys, like that. Okay, so for the word here, we have here and here. Okay, this is not a good way to visualize it. Let's prove. Actually, let's go here and let's say that for this term we have engrams like that. And let's see what we have. Okay, so for mother we have engrams like that, 3 grams, 4 grams, and 5 grams. For this we have only that, and for here we have the following engrams actually. Okay, I think that's pretty clear. So right now we can use engram in our inverted index. Actually. So we had this keyword, we were searching for employee. It still works because right now we are supporting both whole words of the terms and also their from 3 to 5 grams. Okay, so right now if we want to ask for emp, we will get results actually. Let's maybe add also employees here to get more than one result. We have it. And also if we use four letters long prefix, we also have that. And we can also query with the only for suffix. So let's do something like that. Okay, and we get 2 results because this is matching employee, but also employees. Okay, so I think that's it. For today we have covered the basics of full text search and how it works, more or less, in all of the popular search engines like Lucene and Elasticsearch, because Elasticsearch is really using Lucene under the hood. We skipped some more advanced things, but we can cover them in the next video. So if you like the video, subscribe to the channel, and I see you in the next video, guys. See you. See ya.